All right, so today we're diving into something pretty fascinating, I think. Yeah, the intersection of blockchain and machine learning. We've talked about them individually on the show before.
We have. Two huge, rapidly growing fields.
Exactly, and we all know blockchain is all about secure and transparent record keeping. Right.
Immutable ledgers, all that.
Right, and then machine learning, it's all about making sense of massive amounts of data, identifying patterns and trends.
And ultimately driving smarter decisions, making predictions.
Exactly. But what we're really digging into today is how these two seemingly distinct technologies actually can leverage each other's strengths.
The synergy between them. I like that.
So our deep dive today is all about unpacking that synergy. How can blockchain make machine learning better and vice versa?
Can they overcome their individual weaknesses through this collaboration?
That's the big question. We're talking about boosting security, improving efficiency, automating processes, even potentially creating more intelligent systems.
That's a pretty ambitious goal.
Yeah, it is. But the potential here is huge.
But before we get too carried away, it's worth remembering that both of these technologies, they have their limitations.
They do.
Blockchain, for instance, it's amazing for decentralization, security, immutability. But it faces these challenges when it comes to computational cost.
Why the scalability, right.
Exactly. Handling a high volume of transactions can be a real bottleneck.
And on the machine learning side, well, as powerful as it is, there are concerns around data privacy.
Where is this data coming from? How is it being used?
Right. And then there's the black box problem. Some AI models, it's hard to understand how they reach their conclusions.
Lack of transparency. Big problem.
So today, we want to find out, can these two technologies work together to overcome these limitations?
And maybe even unlock possibilities we haven't even thought of yet.
Exactly. Let's start by looking at how blockchain can benefit from deep learning. One area where this is already making a big impact is in security.
Yeah, and it makes sense when you think about it. Blockchain, while secure, isn't completely immune to attacks.
Right. Things like fraud, compromised private keys, those Sybil attacks where someone tries to control a huge chunk of the network.
And that's where deep learning comes in. It can act like a superpowered security system for the blockchain.
So how does that work in practice?
Well, think about financial transactions on a blockchain. You've got all this data constantly flowing.
Right. A huge stream of information.
And deep learning models can analyze this data stream. We're talking about models like RNNs, those recurrent neural networks, which can analyze sequences of transactions over time.
Like they have a memory, right? They can remember past transactions.
Exactly. And then there are CNNs, convolutional neural networks, which are great at picking out specific patterns in the data, almost like visual cues.
So these AI models are constantly watching the transaction flow, looking for anything unusual.
Anything that deviates from the established norms. A sudden surge of transactions from a dormant address. A pattern that just seems off.
And if they spot something suspicious,
they flag it immediately. It's like having an AI security guard that never sleeps.
Wow. So that's for preventing fraud. What about those 51% attacks?
Same idea. Deep learning can analyze network activity, searching for signs that someone might be trying to gain control of a majority of the network's computing power.
So they can essentially predict and potentially prevent a 51% attack before it even happens.
Exactly. It gives the network time to react and put up defenses.
That's pretty impressive. I read that some researchers are even using a technique called adversarial learning to further enhance security.
Oh yeah, that's super interesting. It's like building a virtual red team and blue team within your AI.
A red team and a blue team.
Yeah, the red team is constantly probing for weaknesses, trying to attack the system, while the blue team is trying to defend it.
So it's like they're battling it out, but it's all happening within the AI system.
Exactly. And through this constant competition, this virtual arms race, the AI learns to be more resilient.
It's constantly learning and adapting.
It is. And then there's this whole concept of federated learning on the blockchain.
I saw that mentioned in the research. How does that work?
It's a way for multiple parties to collaborate on training a powerful AI model without actually sharing their raw data.
So imagine different banks, each with their own sensitive customer data.
Right. They want to work together to build a better fraud detection system, but they can't just give each other all their data.
Privacy regulations and all that.
Exactly. So with federated learning, they each train a model on their own data locally.
Okay.
But instead of sharing the data itself, they only share the insights that their models have learned.
The knowledge, but not the raw data.
Right. And they share this knowledge securely on the blockchain. So the blockchain acts like this neutral platform where they can aggregate their learning without compromising privacy.
That's really clever. So we've seen how deep learning can boost blockchain security. What about the consensus mechanisms that are so crucial to blockchain?
Ah, yes. The heart of how blockchains work.
Proof of work, proof of stake, those kinds of things.
Right. And these mechanisms, while effective, can be energy intensive or have other limitations.
So how can deep learning help?
Well, one way is through what's called smart consensus, driven by reinforcement learning.
Reinforcement learning.
It's a type of machine learning where an AI agent learns to make optimal decisions through trial and error.
Like playing a game and figuring out the best strategy.
Exactly. And you can apply this to consensus algorithms like proof of stake. The AI learns to dynamically adjust parameters, like how much stake a participant needs or what the penalties are for misbehavior.
So it's constantly optimizing the consensus mechanism based on real-time network conditions.
Precisely. It makes the system more adaptive and potentially even more secure.
I also read about deep Q networks being used to improve the selection of validators in a proof-of-stake system.
That's another great example. In proof of stake, certain participants get chosen to validate transactions and add them to the blockchain.
Right.
Deep Q networks can analyze a bunch of factors, like the validator's past behavior, their stake size, network conditions, and then choose the best validators for the job.
So it's like an AI-powered selection committee making sure the system is fair and efficient.
It is. And this can even have an impact on energy consumption, choosing validators who are more efficient, reducing the overall energy footprint.
That's a big deal given all the concerns about blockchain's environmental impact. And speaking of challenges, what about scalability? Blockchains are notorious for struggling with high transaction volumes.
Right, and that's where deep learning's predictive power can be a game changer. Imagine an AI that can analyze historical transaction data, identifying patterns that suggest future bottlenecks.
So it can anticipate where the system is going to get clogged up.
Exactly. And based on this, the blockchain can adjust things like block size, transaction fees, even the allocation of nodes across the network.
All in real time to handle the anticipated load.
Precisely. This dynamic adjustment can significantly improve the blockchain's ability to handle large transaction volumes.
It's like building in a sort of traffic management system, but for data on the blockchain. I even saw a mention of deep learning potentially playing a role in Ethereum's dank sharding proposal.
Ah, yes. Dank sharding is all about dramatically increasing the amount of data Ethereum can handle.
By breaking it up into smaller chunks or shards.
Right. But managing and accessing all these shards efficiently, that's a complex task.
And that's where deep learning could help.
Exactly. Optimizing how these vast amounts of data are distributed, accessed, ensuring the whole system runs smoothly.
So deep learning is playing a role in improving the scalability and efficiency of these new data availability layers.
It is. It's fascinating to see how this all comes together.
It really is. We've talked about security, consensus, scalability. What about smart contracts? They're at the heart of so many blockchain applications.
Right. They're amazing for automating agreements and transactions, but they can have issues.
Like bugs in the code.
Exactly. Bugs, inefficiencies, even security vulnerabilities.
And that's where deep learning comes in again.
Potentially, yes. You could train AI models to analyze smart contract code, searching for these hidden flaws before they can be exploited.
Like an AI code auditor, constantly scanning for weaknesses.
Exactly. It could save a lot of headaches and prevent financial losses.
Absolutely. And beyond the core infrastructure of blockchains, deep learning is making waves in decentralized finance, or DeFi.
DeFi is already disrupting traditional finance, and AI is just adding fuel to the fire.
So how are they combining in DeFi?
Well, think about lending platforms like Aave or Compound. Deep learning could be used to power the algorithms that determine loan terms and interest rates.
Making them more dynamic, more responsive to the market.
Exactly. AI could even help mitigate impermanent loss in liquidity pools, a big concern for users of decentralized exchanges.
And then there are those automated market makers, AMMs, the backbone of decentralized trading.
Deep learning can make them more efficient, more effective, and potentially even fairer.
So it's really optimizing all aspects of DeFi. Give me an example of how a neural network might actually be used in this space.
Sure. Imagine a neural network that can perform real-time risk assessments of potential borrowers on a lending platform.
So it's going beyond just credit scores.
It is. It's analyzing a wide range of data points, trying to build a more complete picture of the borrower's financial situation.
This could lead to more accurate lending decisions, better risk management, and a more stable DeFi ecosystem.
Exactly. The possibilities are really vast.
They are. The research also mentions some even more radical ways of integrating machine learning into consensus mechanisms, things like proof of learning and block ML.
Right. Those are fascinating approaches. Instead of just using AI to optimize existing consensus mechanisms, they're actually baking machine learning tasks directly into the process of reaching consensus.
So the act of performing a machine learning task becomes part of how the network agrees on the validity of transactions.
It's a really elegant way to intertwine the two technologies. And you mentioned earlier the challenge of scalability. The research highlights some specific examples of how deep learning can optimize data management on the blockchain, which is crucial for addressing this.
Yeah, the ever-growing size of blockchain data is a huge obstacle.
It is. But research by Liao and others has shown that techniques like Q-learning, a type of reinforcement learning, can be used to reduce latency and improve the speed at which the blockchain reaches consensus.
So it's making the whole system faster and more responsive.
Exactly. And then there's the issue of storage space.
Yeah.
All that data has to be stored somewhere.
And it just keeps growing.
Right. But research by Mao and his team explored using a deep learning framework called Attention UNet to achieve significant storage savings for images on the blockchain.
So deep learning can help us compress and store all this data more efficiently.
Exactly. It can even be used to manage the traffic flow of data across the network.
So it's not just storing the data better, it's making sure it moves around the network smoothly and efficiently.
Exactly. It's like a sophisticated traffic management system for data on the blockchain.
And the research also talks about how this combination can lead to automated decision-making that's more trustworthy and reliable.
This is where the transparency and immutability of blockchain really shine. Imagine a system where AI is making decisions, but every step of the process, every piece of data used, is recorded on the blockchain.
So it's all auditable, completely transparent.
Exactly. This can build trust in the system, especially in critical areas like healthcare.
Give me an example.
Sure. Imagine electronic health records stored securely on a blockchain. Then deep learning models could analyze this data to predict patient outcomes or suggest treatment plans.
And because the data is on the blockchain, we know it hasn't been tampered with?
Right. And the AI's decision-making process can potentially be made transparent too. This makes the whole system more trustworthy and reliable.
It's a powerful combination. And it seems like we're seeing a trend towards even deeper integration between the two, with new consensus mechanisms like BlockML and WeakAcoin specifically incorporating machine learning tasks.
Yes, it's fascinating to see how these two fields are becoming increasingly intertwined.
Okay, so we've explored how blockchain can leverage deep learning. Now let's flip the script. How can deep learning benefit from blockchain?
Well, one of the biggest challenges in AI is the black box problem.
We talked about that earlier. It's the idea that it can be hard to understand how some AI models reach their conclusions.
Right. And this lack of transparency is a big problem, especially when AI is being used to make important decisions.
Like in healthcare, finance, or even self-driving cars.
Exactly. So how can blockchain help? Well, it can provide what's called verifiable AI.
Verifiable AI.
It's the idea of creating a transparent and immutable record of the entire life cycle of an AI model. Everything from the data it was trained on to the algorithms used, all stored on the blockchain.
So it's like a tamper-proof audit trail for the AI.
Exactly. This allows anyone to trace back the origins of the model, see how it was built, and potentially identify any biases or vulnerabilities.
I read that IBM Watson is actually doing this with their AI models.
They are. It's a great example of how blockchain can increase trust and accountability in AI.
So that addresses the transparency of how the AI was built. What about verifying that the AI is actually making good decisions?
That's where decentralized AI model validation comes in. Blockchain can facilitate a system where AI models are essentially peer-reviewed by a network of experts.
So it's like the scientific peer review process, but for AI.
Exactly. And the results of this review process are recorded on the blockchain for everyone to see.
So we're reducing reliance on potentially biased central authorities and creating a more trustworthy system for validating AI.
Precisely. This is especially important in sensitive areas like medical imaging or legal AI, where biased decisions can have serious consequences.
Makes sense. Another area where blockchain can really help deep learning is in training. Training these powerful AI models often requires access to massive amounts of data.
And that data can be scattered across different organizations, often locked away due to privacy concerns.
And blockchain can help break down these data silos.
It can. One way is through the creation of decentralized data marketplaces.
Data marketplaces.
It's a platform where data owners can share their data securely and transparently. potentially even getting compensated for it.
But how do you address privacy concerns?
Technologies like zero-knowledge proofs.
Zero-knowledge proofs.
It's a way to prove you have something without revealing what it is. So a data owner could prove they have data relevant for training a particular AI model without actually revealing the data itself.
So the AI developers can find the data they need, and the data owners can maintain their privacy.
Exactly. And then there's federated learning, which we talked about earlier.
Right, training AI models across multiple devices without centralizing the data.
Blockchain can enhance this by providing a secure and transparent platform for managing the whole process. Recording model updates, verifying contributions, making sure everything is auditable and tamper-proof.
It's like adding a layer of trust and security to collaborative AI development. And the outline also mentioned using blockchain to help with the massive computational demands of AI training.
Ah, yes. Training some of these really advanced AI models can require huge amounts of computing power.
Which is expensive and often relies on centralized cloud providers.
Right. But with blockchain, you can create decentralized networks where individuals can rent out their spare computing power.
So instead of relying on Amazon or Google, AI researchers could tap into a global network of computers powered by blockchain.
Exactly. Platforms like Golem, iExec, and Fetch.ai are already exploring this.
So it's democratizing access to the resources needed for cutting-edge AI research.
It is. And this decentralized approach is also proving useful in the world of cryptocurrency trading.
Makes sense. There's a ton of data generated by blockchain-based financial systems.
Right. And deep learning models can analyze this data, trying to identify patterns and predict future price movements.
So AI-powered crypto trading bots.
Exactly. They're using things like LSTM models, those neural networks that can remember past data, to try to make sense of the volatile crypto market.
And we touched on this before, but it's worth reiterating. Blockchain provides a really secure and immutable way to store the massive data sets needed for machine learning.
Especially in sensitive areas like healthcare and finance, where data integrity is paramount.
And we also discussed how blockchain can incentivize people to contribute to the machine learning ecosystem.
Right. Smart contracts can be used to reward people for sharing high-quality data or contributing computing power for training.
And this whole system is transparent, so everyone can see how it works.
It's a really elegant way to encourage collaboration and build trust in the system.
It really is. And there are platforms using machine learning on blockchain to increase transparency and traceability in other areas, too.
Like supply chain management, for example. Blockchain can track the movement of goods, and AI can analyze all that data to identify bottlenecks and improve efficiency.
It's all about using these technologies to create more transparent and accountable systems.
Precisely. But as with any emerging technology, there are challenges. Integrating blockchain and machine learning isn't always easy.
Right. The outline highlights a bunch of those challenges. Let's dive into those. What's the first one?
Computational costs.
Right, we talked about that earlier. Both deep learning and blockchain can be pretty resource intensive.
They are. Deep learning, especially training those complex neural networks, it requires a lot of processing power.
And blockchain transactions, especially on networks like Ethereum, can be expensive and slow.
So trying to do complex machine learning directly on the blockchain, it can quickly become infeasible.
Too costly, too time-consuming.
Exactly. So people are exploring hybrid models where the heavy lifting of the AI happens off-chain, and then the blockchain is used to store the results or verify the integrity of the computations.
So each technology is used for what it does best. Makes sense. And another big challenge is scalability, right?
Oh, yeah. Some blockchains, like Bitcoin, they can only handle a limited number of transactions per second.
Which isn't ideal for machine learning applications that might require frequent interactions with the blockchain.
Right. So again, solutions like layer 2 scaling and off-chain computation are crucial.
These are ways to increase transaction throughput and make the blockchain more responsive.
Precisely. And then there's the issue of computational cost again.
We keep coming back to that.
It's a fundamental challenge. We need to find ways to make both deep learning and blockchain more efficient, less energy intensive.
More sustainable.
Exactly. Yeah. And then there's the regulatory landscape.
Yes. Regulations. Always a hurdle with new technology.
It's a big one. The lack of clear regulatory frameworks for blockchain and AI, it creates uncertainty for businesses and investors.
They need to know the rules of the game before they can fully commit.
Right. And this uncertainty can slow down innovation and adoption.
Absolutely. The research also mentions some specific challenges related to using blockchain data for machine learning.
Yeah, even though blockchain data is great in terms of transparency and integrity, it can be tricky to work with.
How so?
Well, for one, blockchain addresses are pseudonymous. You don't necessarily know the real-world identity behind an address.
So it can be hard to track individual users or link their activity across different transactions.
Exactly. And that can be a problem for certain machine learning tasks.
And then there's the issue of smart contract code,
Right. Usually, only the compiled code is visible on the blockchain, not the original source code.
which makes it harder to analyze using machine learning.
Exactly. It's like trying to understand a complex machine by only looking at the gears, not the blueprints.
That's a great analogy. And then there's the challenge of finding enough good quality data to train the AI models.
Yeah, labeled data, especially for things like identifying fraudulent transactions, can be scarce.
And if you don't have enough good data, your AI model won't be very accurate.
Right. And then there's this concept of train-test mismatch.
Train test mismatch.
Blockchains are constantly evolving. New transactions, new blocks, new rules.
So a model trained on data from one period might not work so well on data from a later period.
Exactly. The patterns in the data can shift over time.
And then, of course, there are challenges specific to applying machine learning models to blockchain data.
Right. The black box problem can be a big issue. Regulators often want to understand why an AI made a particular decision, which can be difficult with some deep learning models.
Explainability is crucial.
It is.
Yeah.
And then there's the potential for bias in the AI algorithms themselves.
We need to make sure the AI is being fair and not discriminating against certain groups.
Absolutely. And then, again, there's the issue of computational cost.
It just keeps coming up, doesn't it?
It's a fundamental challenge.
Yeah.
And when you're dealing with the vast amounts of data generated by blockchains, it becomes even more pronounced.
The outline also goes into some challenges related to graph machine learning on blockchains.
Right. Graph machine learning is great for analyzing the network structure of blockchains, but it faces its own set of hurdles.
Like what?
Well, it can be difficult to label the data accurately, especially when you're trying to identify illicit activity.
So you might end up with a lot of false positives.
Exactly. And the sheer scale of blockchain graphs can be a problem. We're talking about millions, even billions of nodes and edges.
That's a lot of data to process, even for powerful AI algorithms.
It is. And then there's the need for real-time analysis in some applications, like fraud detection.
You can't afford to wait hours or days for the AI to make a decision.
Right. And then there's the challenge of integrating machine learning across multiple blockchains.
Each with its own data format and rules.
Exactly. Interoperability is a big challenge in the blockchain world, and it extends to the application of machine learning.
And finally, the research mentions some specific challenges related to using machine learning for smart contract analysis.
Right. As we talked about earlier, the limited visibility of source code makes it harder to analyze smart contracts using traditional machine learning techniques.
You're essentially working with a different language, a different kind of code.
Exactly. And that requires specialized AI approaches.
So despite all these challenges, it sounds like there's still a lot of excitement about the future of this combination.
Absolutely. The potential is just enormous.
The outline mentions some really interesting future directions.
Like autonomous AI agents operating on the blockchain, leading to AI-driven DAOs.
AI making decisions within a decentralized organization. That's a big one.
It is. And then there's the idea of self-optimizing smart contracts.
Smart contracts that can learn and adapt on their own.
Exactly. Using AI to make them more efficient, more secure, more responsive.
And what about AI-powered decentralized identity?
That's a big one, too. Using AI to enhance the security and privacy of digital identities on the blockchain.
Could revolutionize how we manage our online identities. And then there's Web3 AI-powered search engines.
Right. Imagine search engines that can intelligently index and navigate the decentralized web, using AI to make sense of it all.
That would be huge. And of course, we need to address those current limitations.
We do. We need more transparent and interpretable AI models for blockchain data analysis.
And more scalable techniques for handling the ever-growing volume of data.
Exactly. And then there's the challenge of applying machine learning to increasingly complex blockchain networks.
Analyzing data across multiple interconnected blockchains.
Right. And we need to develop new techniques for machine unlearning and continuous learning.
Machine unlearning.
Being able to selectively remove the influence of certain data points from an AI model, especially for privacy reasons.
That's important. And continuous learning.
Allowing AI models to adapt to the changing nature of blockchain data in real time.
So they're always learning, always improving.
Exactly. And then there's the potential of Large language models.
Those AI models that can understand and generate human language?
Right. They could be used to analyze blockchain data, understand smart contract code, even help write smart contracts.
That's incredible. And the outline also mentions further integration of federated learning with blockchain.
Yes, using blockchain to ensure the integrity and security of collaborative AI development.
It's all about using these technologies together to enhance trust and transparency.
And we can't forget about the ongoing research into privacy-preserving AI techniques.
Things like secure multi-party computation and homomorphic encryption.
Exactly. Ways to protect data privacy while still allowing for powerful AI analysis.
And of course, the development of more energy-efficient consensus mechanisms is crucial.
Absolutely. Sustainability is key.
So, to recap, we've explored how blockchain and machine learning can leverage each other's strengths to create more secure, efficient, and intelligent systems.
We've also examined the challenges, the hurdles that need to be overcome.
But it's clear that this convergence of technologies has enormous potential.
It does. And as these technologies continue to evolve, who knows what incredible innovations we'll see.
So here's a final thought for our listeners. As blockchain and machine learning become more deeply intertwined, what completely new possibilities might emerge? What kind of decentralized intelligent systems will we create? It's a fascinating question, and the future is wide open.
It is. And I, for one, am incredibly excited to see what happens next.
Me too. Thanks for joining us for this deep dive into the intersection of blockchain and machine learning. Until next time.